Today we have two lessons, L'Hopital rule and optimization. We will solve like 4 parts for L'Hopital rule and 2 questions for optimization. Let us start with the first question where we have a limit. We substitute for any limit. The first step will be substitute. So substitute 0 here will be 0. Substitute 0 here will be e to the power 0, 1. 1 plus 0 minus 1. The answer will be 0. And cosine 0, 1, 1 minus 1, it's another 0. So we can, since we have indeterminate form, we can use L'Hopital. L'Hopital rule, we find the derivative of the top, derivative of the bottom, then we substitute. So we'll find the derivative of 1, 0, derivative of x, 1 minus e to the power x divided by the derivative of cosine, it's a sine x, limit x goes to 0. Substitute 0 here will be 1 minus 1 and sine 0, 0. So 0 over 0, we can use L'Hopital again. So the derivative of the top, the derivative of 1, 0 minus e to the power x. Derivative of sine, it's a cosine x. So here the derivative of cosine is minus sine, no problem. It's still 0 over 0. Limit x goes to 0. Substitute 0 here. Minus 1. Substitute 0 here, 1. So the final answer will be minus 1. See with me here 0 from right, because the limit will be defined at 0 from right, at 0 limit defined. No problem. We say now 0 substituted will be 0 times 0 from right will be minus infinity. So 0 times infinity or 0 times infinity, indeterminate form. So we should convert it to be L'Hopital rule. So this will be limit, and I will write here ln x divide, because with L'Hopital rule all the time you should have top bottom. So this I can make it right, x to the power minus 2 down. X goes to 0 from right. 1 over 0, infinity divide infinity, and now we can use L'Hopital rule, indeterminate this, and this we can use L'Hopital. Find the derivative of the top, find the derivative of bottom, derivative of ln x, 1 over x, derivative of x to the power minus 2, minus 2, x to the power minus 2, minus 1, it's a minus 3. Limit x goes to 0 from right, which means 1 over x and 1 over x to the power 3. Let's raise it up, will be x to the power 3 divide x, and I have 1 divide minus 2, by the way. Limit n goes, or x goes to 0 from right. This will be minus 1 over 2, x squared, limit x goes to 0 from right. Then we can substitute the 0 here, then the answer will be 0. This you can make it as 1 divided x squared if you want, by the way, but it's still correct, no problem. But the derivative top, derivative bottom, then this will be x to the power 1 over x, and this will be x to the power 3. If I raise it up, as you see here, x squared substitute, then this will be the final answer. Another question, and now we have cosine 2 over 0. It's 2 over infinity, it's a 0. Cosine 0, 1, 1 to the power infinity. It's one of the indeterminate form. So how we can solve this question, as we take in our lectures, if I have number to the power all the time, I take this limit, all of it equal to y. And my goal will be to find the value of y. Y equal limit cosine 2 over x to the power x squared, then ln y equal, don't forget the infinity here, limit, and we take that in the class. The len is continuous function, so we can take it len cosine 2 over x to the power x squared. And now we have x squared, one of the properties of len. That's why we take len. The can be before the len. Let me make a line here. And len cosine 2 over x. And as the previous question, almost, x squared will be down, so this will be limit. X goes to infinity, and this will be len y. So len y equal limit len cosine 2 over x divide, I can write 1 over x squared, or it's easier to write x to the power minus 2 like the previous question. So len y, don't forget that len y in all at the end, I will take e to both sides, by the way, to keep it y, because my goal is to find the value of y. No problem. Now we can substitute infinity. Len 1, it's a 0, 1 over infinity 0. So the direct substitution here, 0 over 0, we can use L'Hopital. L'Hopital say the derivative of the top, derivative of bottom, if we have indeterminate form. So what's the derivative here? 1 divide cosine 2 over x times the derivative of cosine, which is sine 2 over x times the derivative of 2 over x minus 2 over x squared. And the derivative of x to the power minus 2 minus 2x to the power minus 3. Len y equal sine divide cosine, it's a tan 2 over x, and x to the power minus 3 would be up as x to the power 3. All of it divided by x squared, limit x goes to infinity. This with this will be cancelled, so this will be limit x tan 2 over x, x goes to infinity, len y, so len y one more time equal tan 2 over x divide 1 over x, limit x goes to infinity. If I substitute, this will be 0. If I substitute, this will be 0. So to make this 2 over x, I will make this 2 and 1 over 2. So this will be this amount. We take it in chapter 2. I think this amount equal like tan tan x over x. When x goes to 0, the answer will be 1. So this will be 2 len y, so y equal e to the power 2. Or maybe here you can use L'Hopital rule again, but I believe we take it before, so no need for using L'Hopital rule again. So the answer will be e to the power 2 for this question. It's a good question, not easy one. One more exercise with L'Hopital rule. Again, we have indeterminate form. When we substitute 0, 1 to the power infinity, it seems like the same. Oh, 1 to the power infinity, 1 to the power infinity. It's fine, no problem. It's better if I bring different question with different case, but both question in the same case, no problem. Now, again, since it's 1 to the power infinity indeterminate form, so what we will do it, we will convert this to be y equal. Every time we have a power function to the power function, we use y. Y equal limit len 1 plus 1 over x all to the power x. So len y equal limit. Oh, already here we have len, so it's an easy question. I think it's easier than no need until, yeah, it's okay. We can keep it as a y. Sorry for that. X goes to infinity. I have the len here, no need for it. So the x only will be here. No need to take len for both sides like the previous question. In the previous question, I have cosine. I add len for both sides here and here to can take this x squared down. But in this question, already I have len, so I can take x down. Y equal limit x len 1 plus 1 over x. And this x should be where now? Down. Y equal limit len 1 plus 1 over x divide 1 over x, x goes to infinity. If you prefer to make it x to the power minus 1, it's okay. But since I have 1 over x, 1 over x, so y equal, now we can substitute infinity here, 0, len 1, it's a 0, 1 over infinity 0. So it's a 0 over 0, we can use L'Hopital. L'Hopital say derivative of this divide derivative of this. The derivative of this will be 1 divide 1 plus 1 over x times the derivative of 1 over x minus 1 over x squared here, minus 1 over x squared, the derivative of the bottom. You can see this amount are equal, 1 up, 1 down. So we can cancel them. Then y equal, don't forget the limit here, x goes to infinity, limit x goes to infinity, 1 divide 1 plus 1 over x. Substitute infinity here, the answer will be 0, so the final answer of this question will be 1. It's a good question, like the previous one. Okay, we don't have the time, so all the time we'll try to make this video short. Your ironwork has construct to design and build 600 feet square, length base is double the width. We have rectangular steel, okay. Length, the base, this, let's say that length, this is the width. The length base is double the width, the length is equal to W. The tank is to be made by welding thin stainless steel pin together along their edge. As a production engineer, your job is to find a dimension where the base and highest that will make the tank weight as little as possible. The weight means the material mean the service area. So our goal here to make SA service area minimum. And from here, we want to make the volume equal 600 feet cube. So SA equal, you know, the surface area equal. First of all, we have six dimension or 6 faces. So for the base, we have 2 times WL plus 2 this H LH plus 2 WH. Now every L we convert it to be W, so this will be 2W, and the value of L from here, another 2W, to 2WH plus 2WH. So we cancel all the L now, there's no L. So this will be 2 times 2, 4W squared plus 4WH plus 2W. 4W and 2W, no, I need to write them twice. The answer will be 6W. Again, we can't find S prime now. Why we can't find S prime now? Because I still have W and H, and with optimization, we should have only one. So there's something else except the double, the width equal, or the length equal double the width. It's this one, the volume, and the volume mean WLH. So 600 equal WLH, but the value of L is 2W, so 2W square H equals 600. So H equal 300 divide W square. So SA equal 4W square plus 6W, and the value of H is 300 divide W square. 4W square plus 300 times 6, 1,800, and divide W, because one of these W with one of these W will be matched. Now I have only W, so S prime of A equal 8W minus 1,800 divide W square. Divide W square, this will be W cubed. So 8W cubed minus 1,800 divide W square equal to 0 to find the critical point. You know, W equals 0. Yeah, that means we cannot make a box, by the way, or rectangular box. So we will no need to take W equal to 0, only solve the upper equation. W cube equal 1,800, as you see, divide 8, so W equal 1,800 divide 8. So this amount by calculator, it's equal 225. I forget the Q here, sorry. Q here. So W equal the third root of 225. Okay, they say here find dimension for the base and the highest. Okay, easily. The base will be L equal to third root of 225. The highest from here, 300 divide W square, that's mean 225 under the third root square. This is the third root. Okay, a farmer has 300 feet of fence, so he have a fence, let's say something like that, and 300 feet. And want to build a right triangle enclosure along a straight wall. We have a wall here, something like this. Okay. And you want to make a right triangle. If the side along the wall need no fence, so the fence will be only two sides, and this should be right triangle. So maybe I can do it like this to have the right triangle here, or I can do it pillar like this, where the right triangle here. If the side along the wall need no fence, find the dimension that make the area on the enclosure as large as possible. Okay, so from the question, that means the right angle triangle should be out. Why? To make this one is the hypotenuse. So this will be like this, almost this will be the right angle. Because we know for the triangle, the opposite of the right angle will be the longest distance, by the way. So something like this. So I will name this as X, this as Y, we don't know. But we know here fence, it's from here to here and from here to here. So we know that X plus Y, both of them should be equal 300. Make area here for this one equal to what? Area. So I have something like this. Let us say this is the right angle. This will be the base. This will be the highest. So area equal half x time y, or half y time x, I don't care. So we cannot find the derivative direct because, as we say, we should have only x or only y. From here, x equal or y equal 300 minus x. So a equal half x times the value of y, 300 minus x. Multiply this here, 150x minus, multiply here, half x squared. This is a. Now x and x, I have one variable. We can find the derivative. A prime equal 150 minus the derivative of this will be x, because the 2 will be here, equal to 0. So x equal 150. And by the way, y equal 300 minus 150. So y equal 300 minus 150, which mean 150. So x and y, both of them equal 150, 150. So make this equal to this. Let's make the area as big as possible, the largest possible area. Thank you for everything. See you in the next video.